Hello students, and let us continue the next class. And this question is related to the section 2 in paper 1, and which contains one or more options are correct. And here the question is the capacitor having the distance between the plates is D applied by the potential V, and if the distance is increased by a factor of D by 2 and D by 2 on the both sides in this way, and the K value is greater than 1 dielectric constant. In this case, if suppose the distance is increased by a factor of D by 2 and D by 2 on the both sides, then what happened? The four options are given. Out of these four options, and which is correct and which is wrong, that is question. So first option is electric field reduced by a factor is 2K, that is first option, and capacitance and voltage and work done. These four factors, how it will change, we need to calculate in this question. And let us start with the capacitance, because we know familiar the relation C is equal to epsilon naught A by D. So here it is filled with a dielectric constant K, so that capacitance in the first case, suppose the first case is A, Ca is equal to K epsilon naught A by D, that is first case. And in case of B, Cb, if the plates between the capacitor are increased, then epsilon naught A by D plus D by K. Actually D is the space here, D by 2 and D by 2 is D, and here D by K. So finally Cb is equal to epsilon naught A by D plus D by K. That is the effective capacitance between the plates, we know it. And Cb is equal to epsilon naught A into K by K into D into K plus 1. Okay, that is the capacitance Cb, that is in the second case. So Cb is finally is equal to Ca by K plus 1. So students, what we proved there, Cb means the capacitance in the second case decreases by a factor of 1 by K plus 1. So the second option is right option given in the problem. And capacitance comparison we proved here. And let us go to the voltage. Actually voltage, we know voltage is decreased by a factor, because here the voltage is increased given. So this is absolutely wrong, because the principle of capacitor explains us that the voltage is decreased by placing dielectric plates in between the capacitor. So here the voltage is increased, thus this is wrong option. And let us go with the first option. See the first option. And electric field in the first case, E is equal to V by D. The potential is V, distance is D, that is in the first case. In the second case, if you calculate electric field, V by D into K plus 1. So if you compare the electric field, that is EB is equal to EA by K plus 1. Like capacitor, electric field also decreases by a factor K plus 1. But here the answer is given reduced by a factor of 2K. So this is wrong option. Okay. So the first option is wrong option, second is correct, and third is wrong option. Finally we are going to verify the fourth option. See, work done delta W is equal to, generally we know half Cb square. So half Cb into V square minus half Ca into V square. And generally we know here Cb and Ca both factors are depend on K, so that work done does not depend on the K is given here. So it is absolutely wrong in this case also, because while you subtracting Cb minus Ca, you get a relation related to dielectric constant, but the factor here given, work done is not dependent, but their work done is dependent. So out of these four options, only one option is correct, remaining three options are wrong. Okay, let us go to the next one. Here one circuit is given, and EMF E1 is 12 volts, here this is E1, and E2 is 6 volts, and every resistance value is same, which is equal to 1 ohm. Then four options are given in this problem. Current flowing through R1. So this is R1. R1 is 7.2 amperes, and R2 is 1.2, R3 is 4.8, and R5 is 2.4. So out of these four options, which is correct and which is wrong, we need to identify it. So that initially if you observe the circuit, all the resistance are equal, so that the potential of A and potential of B are equal, because there is no potential difference between A and B. This R6 and R5, these two are equal resistance, and similarly R7 and R8 also equal resistance. So there is no potential difference between A and B. So this circuit will be converted like, so this is, in this way the circuit is converted. This is EMF, CD points and AB points are merged here, and when AB points are merged here, R5 and R6 are parallel, so that 1 and 1 ohm is parallel. This is 1 by 2 ohm, and here also 1 and R7 and R8 parallel, that is 1 by 2 ohm, and this is R4 and R2, this is 1 by 2 ohms, and this is 1 ohm, this is 1 ohm generally, and this is 6 volts and this is 12 volts. So if you observe the circuit by applying Kirchhoff rule, loop rule, in clockwise direction or anti-clockwise direction, that is your wish, apply the sign conventions in a proper way. And let us take the direction of current in one path, that is I1, in another path, that is I2, let us suppose, and these two currents are passing through the 1 by 2 ohms from here, that is I1 plus I2. So students, this loop is loop 1 and this loop is loop 2. When current passing through loop 1, I1 current and I2 current passing through loop 2, and combinedly the current I1 plus I2 passing in between 1 by 2 ohms, passing through 1 by 2 ohms. Finally here I1 and I2 is divided in this way. So that what is, if you apply the Kirchhoff loop rule to the both circuits, our relations are 1 by 2 I1 minus 1 by 2 I1 minus 1 by 2 I1 plus I2, the next point, and minus I1 plus 6 is equal to 0. So that is one relation, students. So for loop 2, if you observe, in clockwise direction if you take, then 1 by 2 into, this is for loop 2, half I2 plus through 1 ohm, that is I2 plus 12 volts, and that is opposite direction to the current, that is 1 by 2 into I1 plus I2 is equal to 0, and that is for loop 2. So loop 1 and loop 2, if you observe these two equations we derive here, and if you solve these two equations, and finally we get the currents across R1, R2, R3 and R5. So by solving these two equations, and if you identify the resistance, these four options will be correct in this question. So it is very simple question, but a little calculation is needed to prove it. Okay, let us go to the next one. Okay students, let us see the next question. Here a chimney is given, an ideal gas which is passing through the chimney from here to here. Here the area of cross section is given A1, here area of cross section is given A2, and A1 and A2 values are given in the problem, and here the temperature of the gas is 300 kelvins and here is 150 kelvins, and this gas undergoes adiabatic expansion. So adiabatic expansion is happened here, and the ratio of specific heat's gamma value also given, which is 2, and lower end of the chimney, alpha mass per second, how much mass per second of the gas entering to the chimney, that is 0.8 kg per second, and the pressure at lower end is 600 pascals is given. So all these factors are given, whatever we write on the board, and initially the density rho 1 is equal to 0.2 kg per meter cube, which is the density at the lower part. And related to this question, there are 4 points are given in the problem. The first point is pressure of gas upper end is 300 pascals. Here the pressure is 300 pascals and velocity is lower end is 40 meters and upper end is 20 meters, that is second option. And height of the chimney, total height h is 590 meters, that is third option. And density of gas upper end, here the density is given, that is 0.2, and upper end the density, that is 0.05 kg per meter cube. These 4 points are given in the problem. Is the 4 points are correct or not? We need to verify it right now. Okay. So students, let us relate the temperature and density initially, because we calculate the density factor at upper end initially. Temperature and density, actually we know this is adiabatic process, so we know Tv power gamma minus 1 is equal to constant, that is adiabatic equation. So in terms of temperature and volume is equal to mass by density, so that T by density power gamma minus 1 is equal to constant, and finally T1 by T2 is equal to rho 1 by rho 2 whole power gamma minus 1. Okay, so here T1 is given 300 kelvins, T2 is 150 kelvins, so 300 by 150 is equal to rho 1 by rho 2. Rho 1 is the density at lower end of the chimney, which is given 0.2, and rho 2 we need to calculate. So this is whole power gamma minus 1, gamma is 2, so that is 2 minus 1. So finally we get rho 2 is equal to, this is 2 times cancel, and 0.2 by 2, so that is 0.1 kg per meter cube, that is the density at the upper part. But the problem given the density of the gas at upper end is 0.05, but what we get is 0.1. So this point is wrong option. So this is not correct. So one option is deleted in this. So next, the pressure of the gas upper end is 300 pascals is given. It is correct or not? Let us check the next point. And we know the relation according to adiabatic equation, PV power gamma is equal to constant, right? So P by rho power gamma is equal to constant in terms of density, because volume is equal to mass by density. So mass is a constant factor, so that P by rho power gamma is equal to constant, that is P1 by P2 is equal to rho 1 by rho 2 whole power gamma. Okay, so what is rho 1? Rho 1 is the density at lower end of the chimney, which is given 0.2, and rho 2 is the density at the upper end of the chimney. We calculated, that is 0.1, whole power gamma is 2, that is 2 square is 4, and P1 is 300. P1 is the factor 600 pascals at lower end of the chimney pressure, by P2 is equal to 4. Finally P2 is equal to 150 pascals. Okay students, we calculated the pressure at the upper end is 150 pascals, but here the pressure at the upper end is given 300 pascals, so this option is also wrong. So we proved that option D is wrong and option A is also wrong. The velocity of the gas at lower end is 40 meters per second, upper end is 20 meters per second is given. We need to verify it whether those are correct or not. Here the mass rate is given at lower end. Mass rate is nothing but mass by time, that is 0.8 kg per second, but mass is equal to volume into density, right? So the volume into density, that is area of cross section into velocity into density. So A1 V1 rho 1, we write mass rate is nothing but A1 V1 rho 1. So the velocity V1 is equal to 0.8 by A1 into rho 1. So 0.8 by A1 means area of cross section at the lower part, that is 0.1, and density at the lower part, which is 0.2, so that this is equal to 40 meters per second. Okay students, we proved that the velocity at the lower part is 40 meters per second. So here in the answer also 40 meters per second at the lower part of the chimney is given, so that is right one. Next we will calculate the velocity at the upper end, and we know the equation of continuity that a1 v1 rho 1 is equal to a2 v2 rho 2. We know the equation of continuity a2 v2 rho 2. Here a2 is 0.4 and v2 is velocity we need to calculate, and rho 2 is the density at the upper part, which is 0.1 we calculated, and area of cross section is 0.1, and velocity is 40 meters per second we calculated, and density 0.2 at the lower part. So finally velocity is equal to 0.1 into 40 into 0.2 by 0.4. So this is equal to 0.4 4 times 10, that is 20 meters per second, okay, into 0.1. So finally that is 20 meters per second is the answer. So that velocity at the upper end is 20 meters per second. Okay student, we proved the third option is correct because velocity at the lower end is 40 meters per second and velocity at the upper end is 20 meters per second. We calculated velocity at lower end by based on the given data mass rate. Mass rate at lower end is 0.8 kg per second. By using the data we calculated the velocity at lower end, and we know the equation of continuity like a1 v1 rho 1 is equal to a2 v2 rho 2. So based on that relation we calculated velocity at the upper end, which is equal to v2 is equal to 20 meters per second. Okay students, we proved that the second option is right one. Okay, let us go with the third option. Third option, height of chimney 550 is correct or not. Before going to identify whether the option is correct or not, we apply the law of conservation of energy at lower point and higher point. So according to law of conservation of energy, lower point the energy is half rho 1 v1 square, the kinetic energy per unit volume, potential energy per unit, pressure energy per unit volume, that is half rho 1 v1 square plus p1, which is equal to upper end half rho 2 v2 square plus pressure p2 plus another rho 2 g h. So here if you see upper end there is an additional part of energy, that is potential energy. So potential energy at lower per unit volume is also at the upper end in addition to the lower part. So that if we apply the law of conservation of energy and substitute all the values whatever we calculated and whatever they given in the problem, we get h value is equal to 590 meters, because we know rho 1 v1 p1, rho 2 v2 p2 and g value rho 2 etc. So all those values if you substitute, it is possible to calculate the h value is equal to 590 meters. So height of chimney 590 meters is the right option. Okay students, in this problem out of 4 options 2 are absolutely wrong and the 2 options are given the right ones. Okay, let us go to the next one. Okay students, let us see the next one. Here the 3 plane mirrors are given. These 3 plane mirrors are arranged like an equilateral triangle. A small opening is given here, and the light get into the region through this path, and again this is the only path the light will come out. So this is the structure here. So 3 plane mirrors are arranged in this way, and light only having one way to enter in it, and again the only way to come out. So in this case here the side length of the triangle is capital L, and wherever the light ray enter into the triangle, from the corner to that point is taken as small l, and the angle there is theta. So in this case what is there are 4 cases are given here. So the first case is the ray of light will come out for theta is equal to 30 for 0 less than L less than L. So let us suppose first we identify the first case. Let us suppose the light ray will get into the triangle with an angle theta initially. Here this is the small opening. Through the small opening light ray get into the mirrors in this way. So what is the angle here? The angle here is theta, and this is the angle also theta. The angle here theta, and inside angle is also theta here, and this is equilateral triangle, so this is the angle 60 degrees. And if you draw normal, this is normal line. Normal is perpendicular line to that mirror, that is normal, and the normal, the angle here is 60 and this is theta, and this is 120 minus theta. Okay, so here the third angle, because that three angles sum is 180 degrees we know, so that the third angle is 120 minus theta. And here the angle between the normal and the light ray which is inside is theta minus 30, because this is total angle is 90 degrees. So 90 minus 120 minus theta is nothing but theta minus 90. That is the structure. So whenever the light ray enter into the region with an angle theta, then it will reflected in this way, and theta minus 90 is the angle between the normal and the light ray. And the first case we observe here, if suppose theta is equal to 30, let us suppose theta is equal to 30. If theta is equal to 30, what happened? If theta is equal to 30 degrees, then what happened? Theta is equal to 30 degrees means here the angle with the normal and the light ray is 0 degrees. Theta minus 30 is 30 minus 30. What does it mean? The light ray straightly get into the region, and again it will come back. This is the path actually. So the light ray directly go to the structure, and again it will come back into the same path, because the theta is equal to, here the angle made with the normal is equal to 0, theta minus 30 minus 30. So if the angle is 30 degrees, incident angle made with the mirror is taken as 30 degrees for 0 less than L less than capital L. In that case, if the incident angle is 30 degrees, then the light ray will come out through the same path. But what is here given? The light ray come out for theta is equal to 30. So this is right option. So light ray come out because the angle theta is equal to 30 is nothing but straightly the light ray get into the region, and it will reflect it at the mirror, and again it will come back to the same path. So that in that case the light ray come out through the region. So the first option is the right one. Next, if you see the second one, there is an angle L is equal to L by 2 at which the light ray come out after two reflections. And see, if you observe the second one, there is an angle at L is equal to L by 2. L is equal to L by 2 means this is the position, students, and this is the position, because here the small l length is nothing but capital L by 2. In this case, what happened we know, according to the symmetry, the light ray reflected in this way, again it will come back. So if you see, according to the symmetry, the light ray moves in this way. So with 60 with an angle theta, it will get into the region, again it will make two reflections, after again it will come out. So that the point is, here there is an angle L is equal to L by 2 at which the ray of light come out after two reflections. So this is right option, because you see students, here L by 2 is the middle region of the mirror. So middle point of the mirror, when light ray get into the structure, and again it will make two reflections due to the symmetry, because it is an equilateral triangle. The light ray made two reflections, and again it will come out. So that is absolutely the right one. And next point is the right the ray of light will never come out for theta is equal to 60 degrees and L is equal to L by 3. That is the third point is given. Suppose in this case, if you draw the structure, L is equal to L by 3. L by 3. So this is L by 3. Suppose if light ray enters a region of L is equal to L by 3, then what happened? Then it will reflect straightly, it fall on the other mirror, and again it reflects in this way. So this is what happened in this case. So if you see, when a light ray passes through a length L by 3, then initially it fall on the mirror, and after one reflection it crosses the second mirror and third mirror, and again this is the path. So if you see how many reflections are happened, this is first reflection, this is second, third, fourth, fifth. So after 5 reflections the light ray will come out. But what is given here? The ray of light will never come out at theta is equal to 60 degrees. Here theta is equal to 60 degrees. So theta is equal to 60 degrees means here the angle is 60, here the angle is 60, here the angle is 60. So if you calculate, the path is like traveled after 5 reflections, it will again come out. But in the option C is given, the light will never come out. But actually what happened? The light will come out for angle theta is equal to 60 at small l is equal to capital L by 3. So this is a wrong option. Okay, because the light will come out. And next one, the ray of light will come out for theta is equal to 60 and 0 less than L by 2 after 6 reflections. See here, 0 less than L by 2. There L by 3 is in between 0 and L by 2, so that the same case, if you observe how many reflections, here given 6 reflections, but how many number of reflections are happened there? Only 5 reflections. So that this is also wrong options. Okay students, here the problem is given regular hexagon and contains 6 charges on the 6 sides, very near to 6 sides, and here the charge is x. The remaining charges are constant, its values are q, and the distance from here to here and here to here equal is given, which means the distance from center to the side is whatever the distance, the same distance from the side to the charge outside. Okay, that is the point given. And based on this, there are 4 points are given. These 4 points are correct or not, we need to identify. The first point is when x is equal to q, electric field at O is 0. So x is equal to q means, see students, the first point, x is equal to q. X is equal to q means what happened? If suppose x is equal to q, what happened? Here q, here and here and here, and everywhere the similar charge. So with respect to q, the electric field here is in one direction. With respect to q, the electric field is in opposite direction. These two electric field will cancel each other. These two electric field will cancel each other, and these two electric fields will cancel each other. Finally, the electric field, magnitude of electric field at center O is equal to 0. This is the first option, that is right one. So when x is equal to q, the magnitude of electric field at O is equal to 0. And the second point, when x is equal to minus q, electric field at O, x is equal to minus q. Let us suppose the second option, in place of x, if suppose minus q is taken, then what happened? These electric field with respect to these two charges will cancel each other. With respect to these two charges will cancel each other. But these electric fields will make it sum. Why? Because the electric field, the positive charge, and here the negative charge. So these two electric fields along the same direction. So that's why we calculate the electric field at point O in this case. Before we are going to calculate, we need to identify the distance from center to the side. Here the side distance is given a. So a, that is a, and this is a by 2. So what is the distance here? Suppose the distance is y. So y square plus a square by 4 is equal to a square. Finally y square is equal to root 3 by 4 a square, and y is equal to root 3 by 2 a. Okay, so the distance is y is equal to root 3 by 2a. So from center to the charge the distance is 2y, right? Because the distance from here to here also y given in the problem. So the from center to the charge the distance is 2y. 2y means root 3a. Okay, so from center to the charge here, from center to the charge the distance is root 3y. So let us calculate the electric field at center O. So electric field is given, which is equal to 1 by 4 pi epsilon naught q by r square, that is q by r square means root 3a whole square, and into 2, right? Because due to the negative and positive charge the electric field are in the same direction, so the magnitude is make it sum. So 2 into 1 by 4 pi epsilon naught root 3a whole square. So finally 1 by 2 pi epsilon naught q by q square by q by 3a square. So electric field is equal to q by 6 pi epsilon naught a square. Okay students, if you place in place of x the charge is minus q, the electric field is q by 6 pi epsilon naught a square. So the B option is also a right option. Okay, so the option B is also right one, because electric field we calculated q by 6 epsilon naught a square. So second option is also verified. And let us go to the third option. If x is equal to 2q, take in place of x that is 2q, then what is the potential at O? Potential at O, potential we know 1 by 4 pi epsilon naught q by r. So how many charges are here? 2q, 2q, q and q and q. 5 q's plus 2q, that is 7q. So the total potential at O in this case is 1 by 4 pi epsilon naught 7q by, the distance is from here to here, the distance is root 3a. So 7q by 4 pi epsilon naught into root 3a. So 4 root 3 pi epsilon naught a. This is also right option. So if x is equal to 2q, you calculate the potential at a point O. Potential is a scalar quantity we know. So if you calculate potential 1 by 4 pi epsilon naught q by r, but here is 2q, 2q plus q plus q plus q plus q plus q. Finally 7q. With respect to the 7q, potential at point O is 1 by 4 pi epsilon naught 7q by root 3a. So that is right option. The option C is. Let us go to check the option D. When x is equal to minus 3q, potential is given here. So in place of x, take minus 3q. So minus 3q means here q plus q plus q plus q plus q. 5q minus 3q, that is 2q. So what is the potential at O? Due to the 2q, 1 by 4 pi epsilon naught 2q by root 3a. So students, this is the potential due to the entire charges at O if you place x is equal to minus 3q. But in the problem given, that is the potential is minus 3q by 4 root 3 pi epsilon naught a. But actually what is the potential at a point O is q by 2 root 3 pi epsilon naught a. This is right option. So the option D was wrong. Okay, so students, out of 4 options, 3 options are given correct, A, B, C. We verified clearly. It is not a difficult problem, but if you pay attention in each and every option, it is very easy to solve this. Okay, let us go to the next one. Okay students, let us see this the question 14th one. The binding energy of a nucleons in a nucleus can be affected by the pairwise Coulomb repulsion. Pairwise Coulomb repulsion. Assume that all nucleons are uniformly distributed inside the nucleus. Let the binding energy of a proton be EBP and the binding energy of neutron is EBN in the nucleus. Then these are the options given. Out of these, which is correct, which is wrong, we are going to identify. So actually we know the binding energy the binding energy, we know the relation for binding energy is nothing but mass defect into energy, that is C delta M into C square, that is ZMP plus A minus Z into Mn minus mass Mx into C square. This is mass defect into C square, that is actual binding energy without considering the repulsions, but there is a repulsions inside the nucleus. In between the two protons there is a repulsion, but in between the two neutrons there is no repulsion. So due to the protons only, the nucleus face repulsion energy. That repulsion energy due to the protons, EBP, that is repulsion energy due to the protons, is proportionality to Z into Z minus 1 by 2 into 1 by 4 pi epsilon naught E square by R. And if you observe there, 1 by generally potential energy term, we know 1 by 4 pi epsilon naught Q1 Q2 by R is the electrostatic potential energy. We know the relation, and here the potential energy is 1 by 4 pi epsilon naught E square, and each proton having energy, in between the two protons, the energy is 1 by 4 pi epsilon naught E into E by R. The charge is E. And here Z into Z minus 1 by 2 represents the total number of pairs. Let us suppose Z is equal to 2 protons, we have it. Then 2 into 2 minus 1 by 2, that is 2 protons. In between the two protons means nothing but 1 pair. So that's why if you substitute 2, then the factor is 1. If you substitute 3, so 3 protons, in between 3 protons how many pairs? And this is 1, this is 2, this is 3 pairs. So that 3 into 3 minus 1 by 2, 3 into 3 minus 1 by 2 is nothing but 3. So 3 pairs are formed. Suppose 4 protons are there, 4 protons, how many pairs? Here if you notice, this is 4 protons. The possibility of number of pairs is 1, 2, 3, 4, 5, 6. So if you substitute in place of Z 4 into 4 minus 1 by 2, that is 2 into 3, 6. So 6 pairs is formed in this way. And depend on the number of protons, how many number of pairs are formed, that is Z into Z minus 1 by 2 number of pairs of protons are formed. During the pairs, the energy for each pair is 1 by 4 pi epsilon naught E square by R. R is the radius of the nucleus. So the total energy is nothing but Z into, that is proportionality to this factor. And finally EBP is proportionality to Z into Z minus 1. Okay, and here is given EBP minus EBN. So that is EBP minus EBN is also proportionality to Z into Z minus 1. Why? Because EBN is 0. There is no repulsive energy in between the neutrons because they having no charge. So that repulsive energy with respect to the neutrons is unaffected. So EBP minus EBN also directly proportional to Z into Z minus 1. So that the first option A is correct. Finally we proved it. And next EBP minus EBN proportionality to A power minus 1 by 3. See, EBP minus EBN proportionality to EBP minus EBN proportionality to 1 by R, right? 1 by R means radius of the nucleus, and R is proportionality to A power 1 by 3. 1 by R is proportionality to A power minus 1 by 3. So the option given B is also correct. So because EBP minus EBN proportionality to A power minus 1 by 3. And next EBP minus EBN is positive. So students, here EBP is always less than EBN. So EBP is because of repulsion among the protons, the binding energy of protons is less as compared to the binding energy of neutrons. So that EBP less than EBN, so the EBP minus EBN is actually negative, but here given is positive. So this point is wrong. So the third option is the wrong one. And finally the last point is EBP increases if the nucleus undergoes a beta decay emitting a positron. So during beta decay, the number of protons inside the nucleus decreases, which reflects the repulsive force decreases, so that EBP increases. So that this is right option. So this is about the multi-answer questions. Okay, students, and this is about multi-answer questions given in the 2022 advanced question paper. I hope you understand all these questions, and let us continue the remaining part in the next class. Okay, thank you very much.